My name's Kathy Lawrence. This is Jeff Zimmerman and Jason Szymanski. Sorry. And we were making magic slates. As you all remember the magic slate from when you were little and went to McDonald's. There's a pen. And you draw. And you erase. And that's our Workcell that we're doing. We're a second division PLC category. And
yep. As you can see, we were making the magic slates. We've got our cell laid out, kind of in a little logical in order. We've had a slight problem since, about 24 hours before competition, which was we have no controller, I/O. All but 4 outputs have gone on our controller. So we tried to get the best we could and jam the PLC. Okay. Realizing that we had to rewire the whole cell, change everything over. And this is in about 24 hours of time here. So it's a little rough. We've got all our I/O work. Well, not all our I/O. I mean, they'll click the relays and stuff. You can see that they're there. But we haven't had time for programming and fine-tuning. I mean, we've got some rough programming done, but there's no fine-tuning. Our robot programs are good, though. I mean, it will run all positions. Grippers work. I mean, we can pick up a part, but we just can't fully assemble. As for that, we've got our valves mounted on top because we originally had a controller mounted underneath, and we ran out of space. We had limited space. So to save some space, if we mounted our valves on top, we didn't have to do a valve board. Also, you save a little tubing probably running just from there up. You know, little cost effectiveness. Yeah, that's about all I can think right now. We can step through the program and show manually what it would look like. It won't stop anything per se. I mean, at inputs, because like I said, we have to manually stop the robot to let processes go. Okay. Mr. Szymanski, can you
explain everything on a drive before you run it?
Okay.
First of all, we have to say Jason's in back in case of any problems. It's not much of the vocal one, but he's there. Our emergency stop isn't working, so at any time if there's problems, he can stop with the computer back there. Basically what happens is the robot will come and it'll grab this vacuum gripper. It'll come over here and pick up this part.
Just so we can know.
Okay. This part, will be taken and set in our assembly station right there. The robot will then take a wax board with the vacuum gripper, and it'll be holding this surface here like this, and it'll take it and spray with the spray adhesive the backside of the wax board. And this will then be placed here. Well, so that works. Then it'll take the translucent plastic sheet and place it as well there. Sorry. Here, I'll come over here. The Destaco clamp will go down and hold this in place. And does this slide? Not very well. Okay. The staple gun will then slide across and staple it along the top so it's all held together. This will release and the robot will come back and pick up the whole slate and take it to either A or B stamping station. And, this is too hard to lift. Maybe this one will go up. Here, stick that under there, Jason. Whichever was chosen, we can't really do it very well manually, so we just did it every other one in the program now. This will come down and stamp the board. The board and everything that didn't stamp too well will be then taken over there to the exit chute and it will exit the cell. That's our basic process. We have on our control panel This is supposed to be the selector switch for which color stamps, but because we have red and blue, but that's not working right now. This would be an operator restart. It doesn't say that there yet, but it would restart the program if the emergency stop was stopped, pushed, and then it would start right back up where it left off. This is the regular operator start, and this has to be pushed twice. Our air shutoff turns on and off the air, and an air regulator. This is the air gauge to tell how much PSA we have going to our cell. Okay?
Okay. On our operator start, we have an anti-tie-down circuit. So if the operator holds it for more than half a second, it will then kick off and won't let it go. All the process starting and stopping was run on the PLC before we had to cut the robot controller out, basically. Anything else? Oh yes, our wonderful safety. We have our physical barrier, which is the chain in front, designed to keep everybody out. We have an emergency stop there, an emergency stop here. We have an air shutoff valve. On the computer, you can press B for brake. And there's also a stop function at the end of the line where you can choose to stop it.
I might add we intended to have more correct physical barriers, but due to a lack of donation
and lack of light curtains, we ran out. Yeah. Also, we were going to have status lights showing what levels it at. Green for power on, yellow for the cell's running, red for there's a problem, it stopped. What else am I thinking? Oh, we have a power lockout. For some reason, there's a problem. You need to, make sure nobody else goes over. There's a power lockout box right there.
Okay.
It can be opened up, pulled, turned, flipped over, put back in, and no power will pass through the cell. We'll lock out all the power to the computers, the controller, the robot arms.
Grab that over this next cell if you don't mind. Thank you.
Okay.